Alright guys, I know it's been a long time since you've last heard of me, but yeah, some stuff has been going on, and as you can see I switched to Linux and it took some while until I figured out why I couldn't record properly, and that the solution was actually really simple. So anyway, just as quick information, in the repositories there are now all the projects, so if you do one clone or pull or whatever you do, you'll have all the stuff that you need to actually compile and run. The same for a tiled map game, and I don't need to show that. And for that, if anyone cares about it. Also, there is this LibGDX doodles repository now that if anybody is interested in this ridiculously small library, and some people are, I know that, they can do stuff here. But anyway, you don't care about all of that. Let's actually get started and record a new episode. And in this case it is requested. So let's go in here, and I got this request saying I want to make a top-down tank game with Box2D. So this is what we're going to do for now. We are going to create a top-down tank in Box2D. So I'll just do all that in this project because it doesn't have anything to do with the main series. And let's just go ahead into the screens and create a new class. In this case it's gonna be a top-down Box2D tank tutorial screen with the screen interface. So all just like we know it, nothing special in here. And we might want to set up some very basic stuff, like we might want a sprite batch, we might want a world, we might want an orthographic camera with a name, and we might want to import these as well. Also, well, I'll remember the rest later. When we render, we want to clear the screen with gl2.0.gl color buffer bit. When we show it, we want to create all the stuff like world equals a new world, new vector2. That's all what you already know, and I'm just boring you with it, so I'm not explaining stuff. If you don't know what's going on here, you should watch other tutorials, which are also made by me. So batch equals new sprite batch, and camera equals a new orthographic camera. Okay, in dispose we never should forget to do that. Dispose the world, dispose the batch, and dispose the camera. Not just kidding, that doesn't have to be disposed. Okay, so now let's actually get started and create some objects into this Box2D world that we have right here. So what do we actually want to add? We want to add a tank. So we have to create one of those tanks. A tank doesn't exist yet, so the only thing that we can do is create the class. It's not going to have any superclass or interfaces for now. Just click finish and you're left with the most basic class that Eclipse has ever seen. So at first, what does a tank have? Think of that tank in top-down view, and the two main parts that you see are the body chassis, like every vehicle has, and the cannon that fires stuff and is bad for the enemies. Oops, I'm coming from extend. I've been programming in extend the last few days, so I forgot a few things that are very common in Java, but that you don't need to do in extend anyway. Let's create a constructor for this guy, public tank, and it's taking the world in which we want to create it. It's taking a few floats for the position and for its dimensions. We don't have to do it exactly like this, but I'm just doing it in this way because I don't know, I have to do it some way. So yeah, at first we have to create some Box2D objects, fixtures, and all this Box2D basic stuff. So we might want a body definition, which I'm just gonna call body def, and that's going to be a new body definition. This body definition is going to be of the type body type dynamic body, because a tank is moving around, obviously. And since we already have this x and y values here, we can just put them in the body definition dot position using set x and y. Okay, so we already have the possibility to create a body at a position. Let's get a shape for that thing, so it actually makes kind of sense. Polygon shape equals new polygon shape, and that shape is going to be set as box because this is a simple tank, nothing too fancy. And this is going to be width divided by 2, because as you can see, hx is the half width, and height divided by 2. That's it for the shape. Let's go for the fixture def. Fix def, so it's shorter, and it's a new fixture definition. So fixture definition dot shape equals shape. That's like the most important part of that fixture definition. Of course, a tank is pretty heavy, so let's set the density to something high. What is something high? Let's say width. Let's say actually math dot pow, which means the power, and we want to take width, power, height, and that's pretty much. So that's a high density, but what is the problem right here? I think we should cast this to a float, right? So that's gonna be a pretty dense tank, which tanks obviously are. Otherwise they wouldn't be as useful as tanks are. And I'm talking crap. So let's set the restitution to something low, like just .1f. You don't really bounce off of a tank. Fixdef dot friction is pretty normal. Okay, so now we can actually go ahead and finally create a first body, which is the chassis. World dot create body, body definition. Then we can create the fixture on it. Chassis dot create fixture, and we don't want to use this one. We want to use create fixture and give it the fixture definition. So now we have a tank class that simply creates one simple box that's pretty dense that floats around there. I already did one mistake. I just got that. I already did one mistake. Since this is a top-down game, we don't need to set the gravity to -9.81f, but instead we just create an empty vector2, which is exactly the same as this, but we don't need to write it, so I don't write it. Yeah, in top-down games we don't have any gravity, so we don't have to put any in the world constructor there. Then let's create the cannon. This is pretty simple, but a little bit more complicated. Let's just say we set the shape as another box. We can just reuse it, and this box is going to be width divided by 2. This would be how wide the tank is right now, but it should only be a fifth of it. And the height is going to be height divided by 2, so the tank height, and that divided by 3. So yeah, you can imagine it. Then what do we want to do? We want to put the shape into the fixture definition again. I don't know, but whatever. Let's actually let all these other values the same, like density and restitution and friction. Who cares? It's just a cannon. So I don't know if that's necessary. Let's just try to see what happens if we don't do it, and say the cannon equals world.create body, body definition, and cannon dot create fixture, fixture definition. Okay, so now we have two pretty dense dynamic bodies floating around in space. Let's actually go ahead in the menu so that we can even assess this top-down Box2D tank tutorial. This menu is nothing you have, it's just something I have, and you can see I already wrote 1.5 tests for it, but this time we're going for real. So Now I can go into the main class, which I'm just gonna put right there, and actually start this. And Visual VM starts up, but we don't bother with it. We don't bother with it. Goodbye. Top down, but we don't bother with it. Okay. Top down Box2D tank tutorial, and we have absolutely nothing great because I forgot to render it. We're just clearing the screen, but that's pretty boring. Now I know what we forgot. We forgot private Box2D debug renderer, and that's it. Then we need to dispose the debug renderer, and obviously we need to draw with it. So debug renderer dot render world camera dot combined. The camera is created, but still pretty big. So let's say camera dot viewport width equals width divided by 25, and camera dot viewport height equals height divided by 25. And we always want to update the camera. A little bit too many updates at the moment, but later it's going to be useful. So let's just restart this, and there we go. I get a null pointer exception, exactly. So what is null? The debug renderer is null. Okay, you are properly facepalming right now, and so should I. Equals new Box2D debug renderer. Okay, stop this. But now we should finally see these two boxes, I hope. And we should see something that we don't like. At first we don't like that I still don't see the two boxes, because we didn't create the tank yet. Okay, you should really be facepalming. So tank, which is the one that we put up here, this tank equals a new tank, and we have to give it what we put in the constructor here, a world and 4 floats. So the first one's going to be the world, and then let's just say we create it at 0, 0, and it's 3 by 5 meters. And now we should actually be able to see it, and there it is. There's the tank. So now you're probably wondering, I know that this is top down. At first I think the cannon is a little bit too small, but other than that, the two bodies are at the same position, but they're not bouncing off each other, which is simply because I don't update the world yet. So let's just do that. World dot step time step 8 and 3 are always fine for me. Okay. And now they should be bouncing off of each other, theoretically. Restart. And that's already the first problem with top-down games. The cannon is part of the tank, yet it just drives out of it, because Box2D doesn't know this is top-down and stuff. It doesn't have anything to do with top-down or platformer anyway. So what we have to do is we have to connect this cannon with the chassis. So at first I thought the cannon is a little bit too small. I think this will look way better. Yeah, that's more like the cannon. And then we want to put them both like together. So we need to connect them somehow. And how do you connect things in Box2D? That's right, we use joints. In this case, it's going to be a revolute joint to connect the chassis and the cannon. So let's say joint, create a new revolute joint, and fuck, I've always been recording with a little bit bigger stuff here. Appearance, colors and fonts, text font 16. Ah, okay, that should allow you to see way more. So I'm sorry, but you didn't really miss anything yet. So revolute joint def joint definition equals a new revolute joint definition. Import it, and there we go. So now the interesting part. This joint definition is going to have body A as chassis and joint definition dot body B is cannon. You could figure it out this far yourself, I guess, but we want also the joint definition dot local answer B, which is the answer of the cannon, so where we fix that joint on the cannon, and the y of that should be set to the width of the cannon, which is the height of the cannon, which is divided by 3, height divided by 3, minus, let's say, actually that's okay, height divided by 3 is okay, and actually minus height divided by 3. So it's just on the bottom of the cannon, and we don't want to fix the cannon right here so that it rotates around itself. It should rotate around this point, so it can actually look like a normal cannon would. And then we can already go ahead and create that joint. Joint equals world dot create joint definition, and we need to cast this to a revolute joint because it returns a generic joint. So let's go ahead and restart. There we go. So this already looks like a tank. Just for demonstration, and I don't need you, Visual VM, just for demonstration, let's try out what happens if we don't set this. And we'll see that it looks absolutely weird because it is now all fixed in this position, but that's not what a tank really looks like. A tank looks like this. Okay, so now rotates around this point, so it can go like this, woo, and actually act like a tank. Okay, so that is pretty much it for this tutorial, because my screen recorder is not good and I'll have to wait at least 10 hours for this to compress, and so I'll just, yeah, maybe I'll cut them together on YouTube and I'll just cut away all that talk and stuff that I do know, but maybe not, and I'll upload them as separate parts. But of course we'll still talk about how to control this tank, how to put some, I don't know, sprites on it, but that's not really the topic. Basically how to control it, how to drive it around, how to move the cannon, and how to make it shoot. So actually the interesting parts of the tank. Thanks for watching this far, even though I had this on font size 12 or something and you couldn't read anything. But yeah, I don't want to bore you. Goodbye, see you in the next part of this, and yeah, thanks for watching. Alright, welcome to the next part of this Box2D top-down tank video tutorial or whatever. And last time we just did all the boring stuff, which is creating the chassis, the cannon, and the joint to connect these two. But that's not really the complicated part about creating a tank in Box2D. The complicated part is more how to control that thing and how to make it shoot. So let's actually go ahead and do that today. So the first thing that we want to do is we want to have some possibility to send input to this tank. Obviously, to do this we need some form of input processor or something, and since this tank doesn't extend anything else yet, I'm just gonna let it extend the input adapter. That's not really object-oriented nice way to do it. Usually you'd say implements input processor, and that's actually exactly the same thing, but if we extend the input adapter, we just need to yeah, pretty much do nothing, because we have less methods to override. We don't need to override all of them. So let's say for key down we want to do some stuff, And for key up, we also want to do some stuff. Okay, by default, we're going to return true in both of them. And okay, let's get to the theory. At first, I'll just start up the tank test or whatever here real quick, so we can imagine it better. And what do we want to do? So a tank doesn't drive like a normal vehicle. A normal vehicle just has two wheels in front, two wheels in the back, and it can steer with a tool with two wheels in front. But a tank has tracks. It has a left track and a right track, and they can move independently, one forward and one leftward, so it can turn around itself on the place without having to go like this just to turn the direction. It can just go like this and has turned the direction. So we want to apply forces to this tank, not just in the middle to move it forward and not rotate it, but we want to apply one force on the left track and one force on the right track. Of course, we can't just apply force to all of these places here. We're just going to apply one force there and one force over there. Like this we can get the totally realistic tank movement. Okay, and I already noticed again that I forgot to set the font size to 16, so you're mad at me. Okay. Good, so let's actually go ahead and give this tank some variables, which are all going to be floats. The first float is called egg, and I'll just say this is acceleration or acceleration force or power or whatever, and I'll just give that a high number that I figured out previously. You'll just have to figure out the number for yourself or do everything as I do. Your decision. Then you also need another float called left egg and right egg, which is simply the acceleration on the left track and on the right track. That should actually be enough for now, I think. Then in switch, we want to create a switch here in the key down method, switch on the key code, and see what happens. So at first, in the default case, which is none of the keys that we'll define above were pressed, we just want to return false and not true. So we know the input was not handled correctly, but that's minor issue. So keys.q is the first case. In case we press keys.q, we want to move the left track forward. So we want to set left egg to egg, and egg is the acceleration. So left we have full acceleration forward. In case keys.a is pressed, this is a weird, it's not standard WASD steering, it's QAED steering, which just allows you to actually steer the tank how it is steered. So left egg, when we press A, is going to be minus X. So the left track moves, back. It moves not forwards, backwards. Exactly, that's the word. Keys.E is going to be right egg equals X. So on the right track it moves forward. And keys.D moves the right track backward. And that's it. Now for key up, we want to do the same stuff in key up, not exactly the same, but kind of the same, so they don't just keep moving forever. We'd usually set up a switch case, and you can do this, but it's less to type if you just say if key code equals keys.q or key code equals keys.a. We want to set left egg to 0. So Q or A is not pressed anymore, so that track should not have any acceleration anymore. Else if key code equals keys.E or key code equals keys.D, that's for the right track to set to 0. And else return false, but that doesn't matter at all. It's just, again, if the input was handled or not. Probably really doesn't matter for this tank right here. Anyway, so we now have the right egg and left egg variables set to how we currently want to move the tank around. We just have to actually move the tank around according to these variables. For this, we're going to create a new void returning update method. And now it's getting a little bit mathematical. Let me just open up something quickly. Tank test2. And I'll just grab these things here, which are written in extend, so don't get confused, and put them in here. So what's going on there? At first I have to make some kind of Java out of this, put semicolons after everything, and say this is a float, and 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 now I can explain this. After importing math utils and saying get transform and get rotation. Okay, so now I can explain this. The problem is, if we have a look in the tank again, I can just explain it better this way. The problem is, we want to apply some force here and here, but imagine we were pressing Q and E. That would mean we want the tank to go forward. So we have Q and E both on the acceleration speed, or whatever you want to think of it. This will mean he has to accelerate this direction and this direction here. Now imagine the tank would not be in this angle, but he would be looking to the right. Then if we applied the same acceleration on the positive y-axis, he would still be moving in this direction, even though he's looking to the right. So we have to kind of not do this. So we have to get the rotation of the tank to be able to say how much of the right track and left track acceleration should actually be applied to the x and y axis. Because because like this, we want all the left track acceleration go into the y-axis and the right track acceleration as well. But if the tank is looking to the right, we want all of the acceleration go into the x-axis. So always the direction that the tank is facing. We can figure this out by at first getting the transform, and from this the rotation of the chassis body, which is by default looking to the left. So we add math.pi divided by 2 to it, which is 90 degrees in radians. Like this, we'll get from looking to the left to looking forward. And then we can figure out with cosine and sine from this rotation the x and y parts. So it's actually kind of simple math, but I suck at math, so it's hard for me to explain this, and I hope you guys understand. Anyway, we want to now take the chassis and apply a force to it. This takes a vector 2 for the force, a vector 2 for the point, and Boolean wake. I can already say that we want to wake up the body when we apply this force and it's currently sleeping, so let's put a true there. And we need some temporary vector 2, because we don't want to create new vector 2 each frame. That would be garbage collector hell. So let's go here and create a vector 2 temp, and I already know that we'll need temp 2. You can't know that right now, but I do. Also, we want to initialize them. And import the vector2 class, obviously. So the vector2 class has a method called set, which you should already be familiar with, and it says it returns the vector for chaining. So we can just say we set the left acceleration on this vector2, which is left egg times x and left egg times y, That's why we figured out these x and y parts of the left acceleration, or of the acceleration of the left track. And then we can specify the point that we want this force to be applied to. The point on the left track is this point, so it's given in local coordinates, local from the body. So we want to set it to width divided by 2 negative. Okay, let me say that again. We want to apply the force on the left side of the tank, so we have to take the width of the tank divided by 2, because we're starting at 0, 0 and go in negative direction, which is going to be right there. Unfortunately, this point doesn't take a vector 2 in local coordinates, but in world coordinates, I think. Yes, yeah, that's true. So we have to say chassis dot get world point and transform the vector 2 of this position here to world coordinates. The local point is going to be temp2 dot set, and we want to actually see this, what's going on right there. Okay, so temp2 dot set minus width divided by 2, just like I explained, and 0 on the y-axis. So what did I just do? At first, width divided by 2, this width does not exist. So let's actually go up here and create some variables like private float width and height. Let's go here and say this dot width equals width, this dot height equals height, and I can already see the typo. Yep. Okay, so now we just store this width and height variables in case we need them, which is the case in the update method. So what's going on in this line? It's even too big for the screen. Let me just drag this over there so we can actually see what's going on. So we apply a force to the chassis body. We use temporary vector 2s. The set method returns the vector 2 immediately, so this is just like giving it a vector 2. This vector 2 is set to the acceleration on the left track, but only the part that we figured out on the x-axis right here, and on the y-axis only the part that we figured out right there. Then we have to give it a point on which this force should be applied, which we have to give it in world coordinates. So we take the chassis, which has the Sandy method called getWorldPoint, which converts from local coordinates seen from the chassis body to world coordinates. So now the second temporary vector 2 comes in, which we set to the local coordinate of the left side of the tank, which is minus width divided by 2 and no change on the y-axis. This is then converted to the world coordinates by this method, returned and put into the apply force method. The last parameter is just if the body should be woken up if it's sleeping. And yes, it should, because if the tank enters sleep mode and we set this to false, we cannot ever apply any force to it again using this apply force method. So now we just have to do the same thing on the right side of the track, because just steering here is not really useful. The tank has 2 tracks, one there and one there. Chassis dot apply force again, this time for the right. So temp dot set right acceleration times x and right acceleration times y. Just the same as here again. And now we have to get the point that we want to apply this force to, which is chassis dot get world point. We use the second temporary vector 2, set it to width divided by 2, not minus width divided by 2, because this time it's on the right side, no change on the y-axis, and finally say yes, we want to wake the body up if it's sleeping. Okay, I hope these 2 lines aren't too confusing, and I think they should be understandable. Also this math there should be understandable. Even I understood it, and that already means something. So let's test it out. I'm pressing Q, A, E, D, and wait, nothing is happening. How can that be? Alright, don't forget that we put this in an update method that we made, but this update method is never called. So we have to go back into the actual screen, into the render method, and before we step the world, we want to apply the force. So tank.update just before we step the world. And actually, why is camera.update over there? That makes no sense. Okay. Also, since we already have the camera, let's say camera.position.set to tank.get chassis.get position .x and tank.get chassis.get position crap .y, and it's a 2D camera, so no Z. Tank.get chassis doesn't exist yet. Alright, let's go and create it. Getters and setters. Let's set some for chassis, but only the getter. For height, but only the getter. For joint, but only the getter. Left egg, only the getter. Yeah, we can say setter and getter for right and left egg. Temp doesn't interest anybody with the getter, and acceleration both. Canon just the getter. So now we have some nice getters and setters set up, all fine pre-generated. And yes, we need to restart because we added some methods. Also, we need to save this here. And now the camera should position itself right on the tank. It kind of does, but I cannot really rotate the tank. And that is because now the camera always focuses on the tank. We call tank.update, which is why the tank blinks this. I don't know if you can see it in the recording, but it sometimes blinks a little bit because it entered sleep mode, and then we apply the force to it again, which wakes it up. But we still forgot to actually set the tank as input processor. So gdx.input.send input processor, and we have to put the tank in there. And because I love to make things complicated and look confusing, I'll just take the tank and put it in there and create it in there. Wow. Okay. So now we should be able to move the tank around, and as you can see, we are. The tank is driving and doing weird stuff with the cannon because we don't have any controls for the cannon yet. But we can control the tank already. Now there's still one weird thing that you will notice if you actually add some ground or background or whatever to this. So let's go into the render method and go here and say batch.begin, batch.end, and draw some random texture just to see where the tank is actually floating around at currently. So batch.draw, and I'll just, oops, not do this. I'll just give it the Luigi image. This assets class doesn't exist for you, of course. You can put it in there in whatever way you want. I'll also give it minus assets.width divided by 2 and minus assets.get height divided by 2. And this happens if you come from a better language. Get width. There are no automatic getters and setters here. And y assets. What am I doing? Luigi front. Luigi front. I should go to bed. Okay, so I'm just drawing a random texture in this world here, which is really big. At least it should be really big. It kind of isn't. Why isn't that really big? Oh, of course. We still need to set the projection matrix to camera.combined. Otherwise, the batch doesn't have to do anything with the world at all. So now we see some weird stuff going on, and that's how it's supposed to be. So we can already drive the tank around, just drive forwards, but the cannon is still having a big influence on it, which is actually not good. Let's set the cannon's density to something lower so we can control the tank better. Where do we create the cannon? There we create the cannon. So fixture definition dot density equals something really low, and that's actually unrealistic. Density, let's say fixture def dot density, at this position the density is still the one of the chassis, so let's just divide it by 500. Awesome. And create this again. And now we can move around way better, I think. Yes, I can steer on the right, steer left, but this really isn't any realistic tank movement at all. It's like hovercraft. And this is because this world has no gravity, so nothing will ever get stopped. If you apply just this little force to anybody, it will float into infinity. And to stop this in a top-down game in Box2D, we need to simulate the gravity or the friction on the ground or whatever you want to call it manually. So in the show method, when we create the tank, we need to tell him that we want to at first get the chassis again and set a linear damping. So as the name says, it will get damped while moving, so it won't float into infinity. I just figured out that 3 is a pretty good value. I don't really know what value that is, probably % or whatever, but whatever. Also, we want to get the chassis and set an angular damping, because it could rotate around itself into infinity again, which I'll also just set to 3. And I want to do the same stuff for the cannon and also the angular damping. Okay, so this just simulates, yeah, realistic behavior. Alright, I don't have this opened anymore, so I'll just start it up again. There it is. And there we go. The tank now gets stopped. I see that it needs a little bit more motor power, but anyway, we can already drive it around. Let's just give it a little bit more motor power real quick. Acceleration is not 2,000, 20,000, but 200,000 or whatever number that is. So now we can drive around way better. Vroom, 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 vroom. But of course the cannon still looks like, I don't know what it looks like. You tell me what it looks like. But it doesn't look like a real cannon because it always goes to the back. It's more like a flag or something. So this tutorial is already pretty long, so I'll make another part of it or something where we'll add the controls for the cannon to be able to move the cannon around this tank how we want and to shoot some balls. Until then, thanks for watching and see you in the next episode. Okay, let's continue with our top-down Box2D tank tutorial. And right now we got this, and we can move around, we can drive around. But at first let's remove this cannon. I don't know what it's doing there, but it should stop, okay? The cannon should always stay in the position relative to the tank, because that's how a cannon on a real tank also usually behaves. So let's go in here, and what we want to use for this is pretty obvious a little bit. The connection between the tank and the cannon. We are going to use this to stop the cannon from rotating. So this connection is a revolute joint, which we created in previous part of this tutorial, and we now want to add some options to its joint definition. The first thing is we are going to use its motor, and that motor has the possibility to enable a limit of which the angle relative to the initial angle can be. So at first we don't want to say, yes, we want to enable the limit, but then we also want to say, what is the limit? And the upper angle, I don't know, maybe we don't even have to specify that. Let's just try it out, reload, and you see it's already perfect just by saying that we want to enable the limit, because what I wanted to show you is we can say the upper angle is something like minus. Minus goes to the right, and not minus goes to the left. It's in the opposite way, or like you think. So let's say it goes from let's say 90 degrees or 45 degrees, just 45 degrees, but we have to take 45 times math utils dot degrees to radians, because we have to specify it in radians, and the lower angle equals, which is, remember it's the right, minus 45 times math utils dot degrees to radians. So now it also might look a little bit more realistic. We can move around a little bit, but at some point it's gonna stop. And I think 45 is still a little bit much. Let's say it is, I don't know, 20 or something. Yeah, this looks way better, but I still think it's too much. Let's just tweak this a little bit up to 10. Well, down to 10, but whatever. So this already looks way more like a realistic tank that moves around and has all that stuff. So while that's happening, while we are not moving it, it should always stay in a 20 degrees wide area that it can move in. So other than that, we probably want to move around the cannon by hand. We want to control it to be able to shoot at the correct place. So let's say if we press W, we want to do something, and if we press S, we also want to do something. So that's tank controls with the QAED. It's not standard WASD controls as you might have expected. You can make your own kind of autopilot and other controls if you want, but this is just the basics. So anyway, to control the can to the right, we want to take the joint, and at first we want to disable the limit, because if there is a limit enabled, we cannot move it around as much as you just saw. This is going to happen in both cases, no matter in which direction we move. And then we want to set joint dot enable motor to true. So yeah, that also makes sense. The motor of the joint is going to be enabled, otherwise it cannot really move. Second, we want to set the motor speed to some value. So let's just say, in case we are moving the motor to the right, which is W, we have to give it a negative value. So let's just try out what minus 50 does, but I think that's a little bit less or some, I don't know. And for to move it to the left, well, I can really say left and right on the clockwise and counterclockwise. W is clockwise and S is counterclockwise. So there we set the motor speed to 50. Let's try this out. It's not working at all. Okay, that's absolutely amazing. Probably I should just have restarted it, but I don't know if that was the mistake. Did I just say enable limit true? What did I do? I want to set the limit to false. I'm sorry for that. So this should be way better. Obviously it doesn't work then. And yeah, as you can see, 50 is probably a little bit less. But anyway, the reason why it's actually not moving at all, we can see that the limit was disabled again. But it's not moving at all because we still have to give the motor some kind of strength. It has a speed with which it should move, but it doesn't have a strength that it can use to move. So this is going to be defined in the joint definition. We can also set it later in the joint itself, but why do that? Which is going to be max motor torque. And let's just say, I really have no idea what I should put in there. Let's say, I don't know, 50 again, and just tweak these values to something that makes sense. And yeah, this already looks pretty reasonable. Now there's one thing left. I don't press the W button anymore, and it still rotates, and that's a really simple solution because in key up we don't stop this rotating. So let's say else if key code equals keys dot W or key code equals keys dot S. We wanna do multiple things, so we need these, and we want to at first enable the limit again. Second, yes, true, yes. Second, we want to disable the motor, so enable motor to false, and the motor speed doesn't matter, nothing does matter, basically just want to disable it. Okay, let's see what happens. Yes, I can move it around. And now we have this, I don't know if it's an issue or if it's good, but I'd say it is an issue. We can move the motor, the cannon around, and if we stop moving it around, it moves back into its limit. And actually, as you just have been able to see, I turn it like 3 rounds. Now that has been 3 rounds, and well, I've been talking, it's 4 and 5, and now it has to rotate all these rounds back into its initial position. So that kind of isn't really great, isn't it? So I'd prefer it if we rotated to this position there, if it stayed like that, and just the angle, this 20 degrees freedom is applied to that direction that the cannon has been looking at. So let's say we set the limits again. So set limits, there is no set upper limit or lower limit or angle or whatever. We just have to say set limits, and the lower one is going to be joint dot get angle or something like that. There should be something like that. What do we have right here? Not that what we need. Get joint angle. Alright. Why are these confusing names? I mean, if we are taking something from the joint, it's obviously angle is obviously a joint angle. But whatever. It's joint.get joint angle. And since this is the lower limit, I guess, we want to set this to minus 20 times math utils dot radians to degrees. And there's actually RedDEC, it's just a shorter version of radians to degrees. And joint.get joint angle plus 20 times math utils dot RedDEC. So this should set the limits according to the new position. So let's just drive around a bit, and yes, we see there are the limits, it's having some freedom, but then we move it to that position over there, and it's totally not working at all. Isn't that great? Why is that not happening? Why is it not? What's that? Come on. I said you should set the limits to that. Maybe I have to do this another... No, I don't think so. Why is this? Joint.get joint angle plus 20 whatever. Set limits lower upper. Yeah, that's the lower one and that's the upper one. What is your problem? Oh, I said RedDEC, but we actually want to say DEC red because we are converting from degrees to radians and not radians to degrees. That always happens to me, so I'm sorry for that. Whatever. And now let's see. We're driving around and we move this and we have the same freedom, room of freedom, but just in another direction. So if I move this down there and I drive back here, I can move around, and yeah, that's how it is. I can also move this back into this position over there and get the same thing. So this is actually it for the tank controls, except that we cannot really shoot yet. So let's fix this. This is pretty simple. We just have to go in here and say case keys dot whatever you choose. I'm gonna choose space and break. We wanna simply shoot, but this shoot method, function, or whatever doesn't exist yet. So let's go ahead and create it. Public void shoot. So we could do this the effective or ineffective way. Let me think what we are going to do. Let's actually do this the effective way, the better way. Let's just say the better way. And for that we will need a body definition up here. Let's just call this bullet body def, and a fixture definition bullet fixture def. So this is just so we have to create them once. Otherwise we would create them every time we shoot, and that is obviously not this intelligent for performance. So let's say shoot stuff and create this. So bullet body definition is just gonna be body definition because we already have one. Why create another one if we have one? But first we want to set the body definition dot position back to 0, 0, because as you might remember we set it to something else here, but dynamic body is still fine, so we don't have to change that or anything else. So bullet body def is fine. Then the fixture definition is gonna be bullet what am I doing? Bullet fixture definition equals fixture def. But the fixture def needs a lot of changes. At first I call it fix def. And did I really do that? Yes, I did. So fix def dot shape is at first going to be a totally different shape. This is going to be bullet shape, and the bullet shape is a circle shape. Bullet shape equals new circle shape, and we are just going to at first import it, yes I know, and call the correct variable, and then say set radius. The radius is going to be width divided by, and yes, what do we divide it by to get the width of the cannon? Divided by 2 divided by 5. So let's just take this here and put it in here. And actually the bullet that comes out of a cannon is a little bit smaller than the cannon itself. So let's say 2 divided by 6. Right, this should be significant enough. And actually we have to divide this by 2 again, because it's the radius and not the width of the circle shape. Alright, so we have the fixture definition of shape set up correctly, but next we want the density, and the density should be pretty high. Because why? Because we are going to shoot stuff with this. So if this just bounces off something else because its density is too low, it doesn't really make any sense to be used as bullet. It's just not this effective. If we hit something with a bullet, it should actually be pushed away pretty much. So let's say fixture density equals something pretty high. Let's say, well, let's just, I don't know, bullet shape dot get radius, and let's take something high again, math dot pow bullet shape dot get radius power 50. Well, 50 is really much. 25. So this is already a pretty high number, I guess. Yeah, that's whoa, that's a pretty high number. We'll see. And fixture def dot restitution should be really, really low. In fact, I'm gonna set it to 0, because what is that? A bullet from a tank that bounces off of other things? That makes no sense. Also, friction is gonna be, I don't know, pretty high, because if we shoot this at some wall or something, we don't want it to slide at the wall. Yeah, just slide around it and just don't make any damage. We want it to actually hit at that specific position. So I'm just gonna set the friction to 1. Okay, that should be fine. And then we can go ahead and create stuff in the shoot method. So we're just going to say world.create body. At first, where is this world coming from? Where is this world coming from? Yeah, we can say chassis.getWorld, so we can get the world like this. You could also say cannon.getWorld, but the chassis is also fine. They both hold a reference to the world, so we can just use this to create a body, but by the bullet body definition, and on that create a fixture with a bullet fixture definition. So this is all that we need to do in shoot. Pretty simple, huh? Wrong. We need to do some more stuff. At first, let's get this body here and say body bullet. And what is this? I did something wrong. We take this fixture and move it out of there, obviously. So this assignment to a variable makes sense. And next, if we do it like this, the bullet is just created, but it's not flying around at all. It has no velocity, nothing. So we want to set some velocity to this bullet, which we can do by saying bullet.set linear velocity and give it these two floats. Okay, so what are they gonna be? They should be the velocity at first a pretty high velocity, and second into a specific direction again. And do you remember the last time that we needed to get the direction of something to apply forces accordingly? Yep, you're looking at it right now. This is this place here where we have a force, in this case left acceleration, that we want to apply on something, but we have to regard the rotation and take the x and y axis parts of it, which we got from right here. So I'm just lazily gonna copy this over. You could also make a specific method just for that or whatever, but I'm just gonna copy it. And the first thing that is very important is that we don't want to shoot into the chassis direction, we want to shoot into the cannon's direction. Yeah, that just doesn't make any sense otherwise. Also, we have to say x times, or just, I don't know, we want a pretty high velocity, and I guess this is a pretty high velocity, I'd say. So times x and 5 times y. Okay, so that's pretty high velocity. Also, yeah, let's just see what happens, but we are gonna get a little issue, so let's restart this. I don't want to do everything at once to not confuse anybody. So there we go, I can shoot. At first, what the hell is this? I'm driving over here. That was too far away, but I'm driving over here and the bullet comes up there. It has the correct rotation, as you can see. It always shoots in the direction the cannon is facing at, but it doesn't start there, and that's pretty simple because we didn't set the bullet body definition or whatever position. So let's say bullet body definition dot position dot set, and we're going to set this to what are we going to set this to? I have to think a little bit. Oh, well, that's pretty simple. It can also take a vector2, and this vector2 is going to come from cannon.getWorld point, just like up here where we did the same with the chassis. And the local point seen from the cannon is, we can use the temp again, temp.set, all just like in the update method. x0, no change on the x-axis, is it? Yeah. And on the y-axis, well, what's the can width? Can width is the can height. The can height is, we created it up there. Cannon shape. That's the wrong one. Shape. There, that's the cannon height. So let's take this and put it in here. And that's it. So we are shooting from the top of the cannon. I think that's it. Yes, that's pretty much it. Okay, so actually if we set the bullet body dev position right there, why do I reset it up here? That makes no sense. We don't have to do this. But this should already help a lot. Also, I thought the bullet was a little bit too small for my taste, so let's set this back to divided by 5, but divided by 5.2 or something, just because I'm perfectionist, which I not really am, but who cares. So there we go, we can shoot this thing, and it's really pretty fast. Actually, it's so fast, it's just too fast. That's typical Box2D tweaking values. We always need to do this. It's still very fast, but that's okay. And I still think it's a little bit too small. Where do we set that? Here, I get confused in my own code, so this should be better. It's still very small. What's this? I think we don't have to divide by 2 a second time. Yeah, we don't have to divide by 2 a second time because I was saying this is the radius, so we need to take it divided by 2, but actually the width divided by 2 divided by 5 is already divided by 2, so that's already enough. Alright. So we now have this bullet shooting at the tip of the cannon, and we are able to move the cannon around. We are able to drive around without the cannon getting out of a specific range, and we can shoot while we drive and everything. You're probably gonna notice that if you drive forwards, you cannot really. Let's wait until I'm off this Luigi face. Oh my god, monster! So you can see it better. I cannot really move up there because the motor of the joint doesn't have enough strength to get up there. We could change this, I guess, by just saying the max motor torque is something ridiculously higher, and see what happens. I'll just move out of this Luigi. It's a little bit hard to control this guy. And yes, I can now move, but it's pretty fast. So this is just you tweaking the values to whatever your likings are. I'm just gonna set this to 100 and be happy with it. Yeah, so this can already, it can almost move around. Yeah, like I say, this is tweaking values, and you don't want to watch me do this. Okay, I think this is actually it. However you draw on that thing now is yeah, it's your taste, so you can do that however you want. I'm just, for the sake of the tutorial, to show that this is not really totally boring, going to say tank.getChassis.set user data to a new Box2D sprite, which is from my library, so I can't really include in this tutorial, and assets.tank. Import everything, and there we go. So this already should look way better. If I go ahead and say Box2D sprite.draw on the badge and the world, yeah, that already looks way better. Now you don't think, what have we been doing all the time? Okay, I'm not going to bother with a cannon now, but whatever. You can shoot already, you can do whatever you want with this tank. Thanks for watching, and this was just a very basic tank example, of course. Tanks in 2D and not top-down are way more complicated. Whatever. Thanks for watching, and I'll hopefully see you in the next episode.